Again, welcome to Biostat 1. Again, this is a Biostatistics 1. In these lectures, we're going to discuss about range, variance, and also standard deviation. Again, as we started with the mean media mode normally find the central tendency of the data set. Now, the range, variance, and standard deviation, our goal is to see how the data vary, that the spread of the values of the data set. So the higher the standard deviation, the higher the variations of the data. Same also applies to the range and variance. So again, in this lecture, our goal is to study the spread of our data set. So here we're going to discuss about range, interquartile range, variance, and also standard deviation. So we start with the quartiles. And here we are giving an example here that if we have sometimes two distribution of data sets, we can say the two distribution can be quite different, yet they have the same mean. So we have two data sets, site 1, site 2. The data set values are quite different, but when we find the mean, they will be almost the same. But this is why sometimes, again, the spread of the data is very important. Finding the standard deviation of the data is this will give us how the data varies. The mean doesn't give us how the data varies or the variations of the data, whether high or low. So this data compares particular matter in hair samples, which is in microgram per meter cube at two sites. Both sites have a mean of 36, but we can see that site 1 exhibits much greater variability. And we can see how the data is spread. We have from 2.2.4 up to 8.6. And when we look at site 2, we can see all the data is in one. Actually, it's from 3.2 to 4.0. So site 2 standard deviation will be very small because the variation of the data is very small. But in site 1, all the way from 22 to 86. So again, the standard deviation will be very high because the variations are very high. And in basic statistics, we start with the descriptive statistics. Descriptive statistics is trying to describe the data, summarize the data. So only the mean median mode is not enough. We know the central tendency, but we should know how the data are spread also, which is very important. Sometimes it's even more important than the mean or the central tendency of the data. So how do we find the range? The range, we normally take the difference of the maximum value and the minimum value. So we can see site 1, the highest value is 86, the lowest value is 22. So site 1 range is 86 minus 22, which gives us 64. Now when we look at site 2, the lowest value is 32, the highest value is 40. So we get 40 minus 32, which will give us 8. So the lower the range value, again, the lower the variation of the data. The higher the range value, the higher the variation or the spread of the data. So here it is a sample range. We tend to underestimate the population range. So always supplement the range with at least one additional measure of spread. So only the range, again, is not enough. So one additional measure of spread, such as standard deviation or variance, also is very important. So next we go to what is called the quartiles. Quartiles normally will give us the top 25%, top 50, top 75% location of the data. So quarter 1, we cut off the bottom quarter of data, which is the median of the lower half of the data set. Quarter 3 will cut off the top quarter of the data. So the median of the upper half of the data set. Then interquartile range will be the difference of quarter 3 and quarter 1. We also have quarter 2, but here we didn't mention it because quarter 2 is the same as the median of the data set. So this is a data set given to us, and they tell us we should find the Q1, Q2, Q3. In these lectures, first we are going to put the data in an increasing order. We sort it in increasing order. So here we can see from 05 all the way to 52. Then the middle value of all the data set is the median. So here, for example, we have our data set is 10. So which means we are going to have 2 middle values, which will be 27 and 28. So we find the average of 27 and 28. Now, if the total data set, let's say it's 9, odd number, we get only 1 middle value. So here we have 05, 11, 11, 2, 1, up to 52. When we count the number of data sets we have is 10. So the median will be at the position of, again, 5 and 6, so 2 middle values. So we find the average of the 2 middle values, which will give us 27 plus 28 divided by 2. Then the answer we get will be the median also, but we say Q2. Then we go to the left, we divide the data set into half. Then we go to the left side, the lower part of the data set. That means now we have 5 at the left, 5 at the right. So the middle value will be only 1, the third position. So Q1 will be 21. Then I'll go to the right side, 28 to 52. The middle value is 42. So Q3 will be 42. So again, the way of finding the quartiles are Q1, Q2, and Q3, is to first step, arrange all your values, the data set data or the values in ascending order, increasing order, sort it, arrange it. Then take the middle value. If the number of data set is an odd number, the middle value will be only 1. If it's an even number, the middle value will be 2. So here we have even number because we have 10 values. So the middle value of the whole 10 will be 2, which is 27 and 28, which is position 5 and position 6. So we find the average of 27 plus 28 divided by 2. Then we divide the value into 2. The left side we have 5 now. The right side we have 5. The lower side we get a Q1. The middle value will be only 1 since it's 5. 5 is a odd number. And the right side also, 5 is an odd number. So the middle value is only 1, which will be 42. Then to find the interquartile, we find the difference of Q1 and Q3. So this will give us 42 minus 21. So most of the time we use the interquartile to find what we call the lower fence and also the upper fence, which is the lower outline data and also upper outline data. So the quartiles, again, this example 2, we have a data about metabolic rates, which is calories per day or carb per day. You can see that here we have our sample size is 7. So our values are 7. First, we arrange it in increasing order. Then the media, we take, this time the media will be only 1 because the total value again is 7. So 1614 will be the media. That's the middle value. So here we say when n is odd, include the media in both halves of the data set. So if I'm going to look for Q1, I will include 1614 to the left. If I'm going to look for the Q3 for the data set, I will include 1614 to the right. So the bottom half will be 4 values, 1362, 1439, 1460, including 1614. So which means the media will be 2 values now. Since the left side is 4 numbers, even the right side also be 4 numbers. It's an even number, so we get two middle values, which will be the average of 1439 plus 1460 divided by 2. The answer will give you 1449.5, which is Q1. Then we go to the upper side. We start with 1614, 1666, 1792, 1867. Then the middle value again will be two values, 1666 and 1792. So add the two numbers, 1666 plus 1792 divided by 2, that will give me 1729. So that will give me the Q3. So now we know how to find the Q1, Q2, and Q3. Now to find the interquartile, we'll say the difference of again Q3 minus Q1. Now the next step, we have something called the 5-point summary. Sometimes we may use a box plot, which is more or less a graphical representation of data, and it will give us the location of Q1, Q2, Q3, and actually Q0 will be the minimum value in the data set, and Q4 will be the maximum value in the data set. So if I have this 5-point summary, I can plot the box plot diagram. So we say Q0 is the minimum value, Q1 will be the, which we found before, 25 percentile, Q2 is the 50th percentile, which is the median, Q3 is 75 percentile, Q4 will be the maximum value in the data set. So to calculate the 5-point summary, we draw a box from Q1 to Q3 with a line at median. Then we calculate the IQR and the fences. So as I said earlier, the interquartile, which is IQR, is always used to find the fence lower or fence upper. Sometimes we say lower fence or upper fence. Lower fence means the minimal outline data, and upper fence means the maximum outline data. So lower fence will be Q1 minus 1.5 IQR, and upper fence will be Q3 plus 1.5 IQR. Normally we don't draw the fence, but in some textbook we use a red X to represent the fence, which will be up if it's outline. So now determine if any value lies outline the fences. That's the outside value. So whatever value I get for fence lower and fence upper, if it's way minimal than, excuse me, the minimum value, or way higher than the largest value, then we have an outline. So let's see an example. So what we mean is this. Now we have a data set here. First, we have to make sure the data set is sorted. Otherwise, we need to sort it. When I look at this data set, it seems it's sorted increasing order. So again, this is example given to us. And in this example, we are going to construct the box plot. So in order to get a box plot, we need that 5-point summary data, which is the maximum, the minimum, Q1, Q2, Q3. And also there we can find the upper fence and lower fence. So we need to find the interquartile, and we'll see that those two values lie outside the minimum value or the maximum value. So what we did first, we look at the data set, it's in an increasing order. So we finish with that. Then the 5-point summary means we need to find the median. So this data set, 1, 2, 3, 4, 5, we have 10 data sets. So the median will be 27 plus 28 divided by 2, which will be the Q2 or the median. We need it for the box plot. That will be the middle line in the box. So we have our, actually that's what is here, 27.5. Then I'll take the first 5 values. So Q1 will be 21, which is right here, 21. Take the last 5 values, the middle value is 42, 42 is here. The maximum value is 52 is here, and the minimum value is 5 is here. So we have the 5-point summary. Now with this data, we can plot the chart. So we can go down to the next step here. So you can see the chart. The range is from 0 to 60. We have Q1 to be 21, so a little bit above 20. And Q3 is 42, a little bit above 40. Then the middle value will be 27.5, so below the 30. And then the minimum value or the lower inside is 5 for the minimum value. And the highest value or the upper inside is 52. Our data said the highest is 52. The lowest is 5, so that's a maximum. So we get our 5-point plot, we finish. But now we want to see if there's any outline. Now outline means if I find the outline value and the value is greater than 5 or less than 52, then we will say that 5 and 52 are also outline data. So we find the IQR first, which is Q3 minus Q1, 42 minus 21, which is 21. Then we find the fence upper, which will be Q3 plus 1.5 IQR. So that will give us 42. Q3 is 42 plus 1.5 times 21. And when we do this calculation, we get 73.5. Where 73.5 is way bigger than 52. So our data is not, there's no outline upper value, higher value. Now let's look at the lower fence, the lower value. We have Q1 minus 1.5 IQR, so we have 21 for Q1 minus 1.5. IQR is 21 also. So we see that we are going to get a value that will be negative because 1.5 times 21 will give us somewhere around 32.5 or something. Minus 21 minus any value greater than 21 will give me negative value. So the answer is negative 10.5. And here we have the minimum value is 5. So which means we don't have no outline for both lower section and also the upper section, because those two outliers outside the data set. So here, we say non-values have above upper fence or below lower fence. So the upper side value is 52 and the lower side value is 5 from the data set. So this is a second example here. They say we should illustrate example box plot 2. So first I'll look at the data set. It seems like they already sorted it for us. So it's already sorted. So my next step is to find the 5-point summary. So here I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Again, 10 values. So the middle value will be the 5th and 6th position, which is 25 plus 26 divided by 2. And that will give me 25.5. Then I'll take the left lower 5 values. The middle is 21, so Q1 is 21. Upper 5 values, the middle is 29, so Q3 is 29. The maximum value is 51 from the data set. The minimum value is 3. So we get our 5-point summary. The minimum, the maximum, Q1, Q2, and Q3. Then next we find the IQR. This is to check if there's any outline data within our values. So IQR will be 29 minus 22, which is 7. So upper fence will be Q3 plus 1.5 IQR. So that will give us 28 plus 1.5 times 7. 7 is the IQR. And that gives me 39.5. And then we can see that this time the 39.5 is inside the value. So this means 51 will be outline. Then lower fence, Q1 minus 1.5 IQR, 22 minus 1.57. And that gave me 11.6. So 11.6, 3 is here. So we're going to get the outline. So we see that we have one above top fence, which is 51, and also one below bottom fence, which is 3. 3 is way less than 11.6, so we have outline. So the upper inside value is 31, and the lower inside value is 21. The next, we're going to draw the whiskers. So here, that's why it's called fence. It's like a boundary. So since 21 is bigger than 11.6, then we are going to keep 21 as our regular value. So 3 will be outline. And here also the same thing says 51 and 39.6 is less than 51. 51 is outline. But we're going to keep 31 because 39.5 is bigger than 31. So actually we're going to keep, our value should be 21 to 31. So that's the box plot. Again, we have the minimum, the maximum, the Q3, Q2, and Q1. Then this is the outline for what we calculated, 3 and then 51. So another example, we have a 7 metabolic rate. Since this data is 7, I will get only one middle value, which will be 1614. So 1614 will be our median. And I'll take the left side will be 1369, 1439, 1460, and 1614. So we have two middle values. So 1439 plus 1460 divided by 2. And that will give me 1449.5. Then the same thing, we use 1614 to the right. So we get two middle values, 1666 plus 1792 divided by 2. And that gives us 1729. So now we have our 5-point summary. The next we find the IQR, which will be the Q3, which is 1729, minus the Q1, which is 1449.5. So that gives us 279.5. Then if I know the IQR, I can find the first fence upper and fence lower. So that will be Q3 plus 1.5 times IQR. So we get 1729, which is Q3, plus 1.5. IQR is 279.5. We do our calculation, we get 21.4 to 2148.25. The lower fence will be Q1 minus 1.5 IQR. So 1449, which is Q1.5 minus 1.5 times 279.5. And that gives us 1030. So none of them is outside. We can see the lowest is 1362, so 1030 is outside. And then the upper is 1867, we have 2148, so it's outside also. So there's no outline. And then the whiskey box plot or the box plot is what we have here. So we have our lower value, the upper value, the Q3, Q2, Q1. So what is, how do we interpret a box plot? First, location. Location will give us the position of the media, or also the position of the whole box, which is Q1, Q3, Q1, Q2, Q3. So we can see here the position is down, mostly down. The position can shift a little bit up, which means most of the values are high. Also, we can know the spread. So knowing the range spread, IQR, that will give a whiskey to whiskey spread, and also the range. Then the shape will be symmetry or direction of skew. Or sometimes we have a long whiskers, the tails, indicating liptokurtosis. So this is an example. We have a box plot A and box plot B. We can see that A means the spread of the data is very, very small. But B means the spread is normal. even spread more when the values are getting bigger. So next we move to the standard deviation. Standard deviation is very, very important. It tells again as how the data is varies or spread. So it's the most common descriptive measure of spread, the most common. Now it's based on deviation around the mean. So the figure will demonstrate. So I have a data set. How can I know how the data vary? First, we find the deviation. For example, the deviation from 40 to 36 will be 40 minus 36. The deviation from 36 to 37 to be 37 minus 36. So you find the deviation each from the mean to each value. So 40 and 36, 39 and 36, 38, and divide by the number of values and find the square root, and that will give you the standard deviation. So here we say the data point 33 has a deviation of what? 33 minus the mean, which is 36. And the data point of 40 has a deviation of 40 minus 36, which will give us 4. And again, 33 minus 36 will give us minus 3. So first we find a deviation, which will be the sum of each value from the mean, or the sum of each value minus the mean. Then we find the sum or square deviation. And that's the sum. First, here we find the difference of each value with the mean, each value with the mean. Difference of one value and the mean, difference of two second value and the mean. Then after that, we find the sum of square deviation. We square all the difference. Now, if we had all the difference, the total will be 0 because there are some values that will be greater than the mean and some values less than the mean. So if you combine, you get 0. Actually, that's why in standard deviation and variance, we always find the square of the deviation. So sum of square deviations. Then from there, we can sum it now. Our answer will not be 0 because any negative value, we square it, we get positive. Then after that, we know the sum square. So to find the sample variance, it will be the sum square deviation divided by the sample size minus 1. And then to find the standard deviation, we find the square root of the variance. So it will be square root of S squared. So that's the formula for standard deviation. This is for sample 1 over n minus 1 times the sum of the difference of each value and the mean or square. So this is how we find, sometimes it's good to use a table like this to find the standard deviation because again, we have to subtract the mean from each value and then sum all. So here we are assuming we have the values here, xi, that's s1, 2, 3, 4, 5, 6, 7, 8. So we have an 8 data set here. To find the deviation, we find the difference of each value and the mean. So we can see the values here. Now I have -2, -3, -4, and I have 2, 3, 4. So if I don't sum it, I don't square it, the sum of the deviation always will be 0, and that's what we have, 0. So I have to square each deviation, which we call the square deviations. So 0 squared is 0. By this time, 2 squared is 4, 3 squared is 9, 4 squared is 16. 0 squared is 0, -2 squared is 4, -3 squared is 9, then -4 squared is 16. So we can find the sample variance and also standard deviation. So we plug in the value of the sum square. Again, the table we have 58 for the square deviation. So that's what we're going to use here. 58 divided by n minus 1. This is sample. If it's population size, it will be 58 divided by 8. The standard deviation also find the square root of the S square or the sample variance. So that will give a standard deviation, square root of the sample deviation. So the interpretation of standard deviation, we say it measures the spread. So for example, if a group was S1 equal to 15 and group 2, S2 equal to 10, then we say group 1 has more spread because the standard deviation is higher. S1 is 15, S2 is 10. So group 1 has more spread. Then we have the rule for 68, 95, 99.7 rule, which will be next slide. The concept here is that 1 standard deviation is 68%, 2 standard deviation 95, 3 standard deviation is 99.7, how data is distributed. And we use the concept of Chebychevs Rule. So here we say that normally distributions, 68% of the data is always in a range of mean plus or minus 1 standard deviation. 95% of data in the range will be mean plus or minus 2 standard deviation. And 99.7% of data is in the range of mean plus or minus 3 standard deviation. So here we have an example that suppose a variable has a normal distribution with 30 and also 10 standard deviation. Then we can say 68% of value will lie between what? 30 plus or minus 10, because 1 standard deviation. Standard deviation is 10, as we have it here. 95% of the data will be lie between what? The mean, which is 30, plus or minus 2 standard deviation. And we can plug, the standard deviation is given to us to be 10. So we can plug it and we can see our interval will be, distribution will be 20 to 40, 10 to 50, and the last one will be 0 to 60. And Chebychevs Rule said here that states at least 75% of the values will fall in the range of mean plus or minus 2 standard deviation for any shape distribution. So here, distribution with a mean of 30 and a standard deviation of 10 has at least 75% of the values in the range 30 plus or minus 2 times 10. So here, why do we choose summary statistics? It's always a report measure of central location, which is the central tendency, our previous slides, mean, median, mode. And also it can measure the spread of the data and also the sample size. The symmetrical mode shape distribution, we may have a report mean and standard deviation. Then a hard shape distribution will report 5-point summary or median IQR. We can also use the software and calculators to check out. So this will be again the conclusion of our lectures in how we can again determine the spread of a data set by using the variance, standard deviation, and also the range, and also the interquartile, Q1, Q2, Q3. Find the fence upper, fence lower. So again, wish everybody the best. Thank you for your time.